we geologists have a saying that the present is the key to the past, but I also believe that the present is the key to the future. And global climate change is increasingly being tied to the increase in emissions and greenhouse gases from human industrial activities. It's certainly evidenced by thoughts about recent Hurricane Sandy. Regardless of one's personal stance on global climate change, we as scientists have a responsibility to undertake research that examines the balance between energy and the environment. You can see here on this map a link between the sources of CO2 in the country and the possible places where CO2 or carbon dioxide might be stored. We at the Advanced Energy Technology Initiative at the Geological Survey are undertaking a set of research about geologic storage or sequestration. There are 3 different types of sequestration. We as geologists really care about what happens in the subsurface. So you might ask yourself, where are we, or what are we thinking when we think about carbon storage, and where are we going to store? So we look at rocks that were deposited 100 million years ago or more in the basin of Illinois. We have sands that are deposited by rivers on top of sands. You can see a close-up picture of that here. When you look at these sandstones under a microscope, what you see is a significant amount of pore space. That blue space is from a thin section that shows where we might be able to store carbon dioxide. Currently stored in these spaces is brine that's on the order of 6 times saltier than the ocean. So once you have stored carbon dioxide, you want to make sure that it stays in place, and so you look for a package of rocks where you have a sandstone which is overlain with a shale, which is highly impermeable, and it's this package of permeable and impermeable rocks that gives us a place where we look for the storage of CO2. What you see here is a vertical map called a stratigraphic column. We geologists like to think from the bottom up. So at the bottom of this stratigraphic column is the Mount Simon sandstone, which you see is in yellow on this cross-section map here. So what we're looking at doing in a demonstration project that we have going on in Decatur, Illinois, is storing carbon dioxide in the base of the Mount Simon. This is a photograph of the drill rig from this project, where we are engaged with Archer Daniels Midland, Schlumberger Carbon Services, the Illinois State Geological Survey, Kentucky and Indiana surveys to store 1 million tons over 3 years. We do a lot of other work besides just the storing of CO2. We have environmental monitoring and baseline activities that have taken place and continue to take place at the surface. We've been doing this work since 2007. We also have deep monitoring wells where we measure the pressure, temperature, and reservoir fluids of the carbon in the reservoir where the carbon dioxide is being stored over time. You can see here some of the activities that have gone on. We're very fortunate at the State Geological Survey to have our own drilling rig. So we've drilled shallow groundwater wells for monitoring on the order of about 150 to 400 feet, depending on where you look. This is the compression and dehydration equipment that is built at ADM. Once we capture the carbon dioxide from ethanol production, then we have to remove all of the water and compress it so that it becomes supercritical and is able to inject for storage. And you can see that this is the first time that we've, in the country, that we've had the opportunity to build an integrated project where we go all the way from capture through a mile pipeline to the wellhead where we inject. Here's the wellhead at the project. If you were to come out and visit us, this is what you would see. We began injection on November 17th, 2011, and I'm very proud to say that we have been injecting for just about exactly a year. As of the time that this slide was done, we had 320,000 tons in the ground. It's a little bit more than that. We inject 1,000 tons a day, so you can do the math. We are not the only project that is like this around the world. What we do, I actually just yesterday came back with my boss, Rob Finley, who's the principal investigator on this project from Japan and Taiwan. We spend a lot of time talking and sharing with other projects around the world, such as Insula, which is in Algeria, Sleipner, which is under the North Sea, and a wide variety of other projects around the world. So thanks very much.